we want to summarize what we've talked about for the last week or so. So we begin with the idea that if y is a quadratic function of form at squared plus bt plus c, we've derived the formula y prime equals 2at plus b. You recall that we derived this formula from the fact that for any 2 points, for any 2 clock times t and t plus delta t, our change in y is y of t plus delta t minus y of t. Our change in t is, of course, delta t, so the ratio, or the average rate at which y is changing with respect to time, is delta y over delta t, and that's equal to this expression. Now when we have this expression, we go ahead and do some algebra. And when we do the algebra, we get the limit, well, we get an expression for y of t plus delta t minus y of t by plugging in t plus delta in for t, and then just plugging in t for t, subtracting the two expressions after doing a few manipulations. And we get an expression, a simplified expression for delta y over delta t, and we take the limit of that expression as delta t goes to 0. When we do that, that gives us an expression that can be denoted dy dt, or y prime of t if we want to emphasize the time dependence, and that expression is 2at plus b. Now what's the meaning of this expression, delta y over delta t? We can move in a little bit closer. And we can see that the meaning is delta y, in the context that we've been dealing in, is the depth change, the change in the depth of the water in the cylinder. Delta t is the time interval over which the depth changes, and delta y over delta t is the average rate of depth change. The limit as delta t goes to 0 of delta y over delta t is the instantaneous rate. If we take an even closer look at this somewhat poorly drawn graph, actually it's fairly well drawn, it's just drawn in too small of an area and it's cramped, but we see that what we're doing is we're taking the point where clock time is t, we got the clock time t and the y coordinate y of t, and then we go to the point where clock time is t plus delta t, so the coordinates are t plus delta t, y of t plus delta t. We've got a delta y between y of t and y of t plus delta t, and we've got a delta t here. And the slope is delta y over delta t. Once more, an instantaneous rate is what we get when we let delta t approach 0.